This video explains the Learning Astronomy by Doing Astronomy Activity 5 titled Altitudes of Objects on the Meridian at Your Location, which reinforces the material of Section 2.1. The learning goals of this activity are to reproduce the altitudes of the North Celestial Pole, Celestial Equator, a star, and the Sun at solstices and equinoxes on the meridian at your location, and to explain why there are different seasons throughout the year, and to explain how stars appear to move through the sky and how motions of the stars differs when viewed from different latitudes on Earth. This lecture builds on material in the celestial coordinate system and the horizon coordinate system. The celestial coordinate system has right ascension and declination. These are called the equatorial coordinates. The elevation and horizon azimuth are part of the horizon system. The following terms are used: latitude, zenith, meridian, elevation angle, celestial equator, north celestial pole, south celestial pole, and declination angle. As a quick review, I'll explain the lines of latitude on the globe. These are called parallel since they lie in planes that are parallel to the plane of the equator and cross Earth's axis at right angles. They run in an east-west direction and measure the distance north-south from the equator. Parallels never cross each other, and they all cross the prime meridian at right angles. Lines of latitude get shorter toward the poles. The only line of latitude that is greater is the equator. It is the longest latitude line. There are 5 special lines of latitude and 1 special line of longitude. By international agreement, Greenwich, England was set as the 0-degree longitude in 1884. It's called the prime meridian. The intersection of the equator, which is the 0-degree latitude, and the prime meridian, which is the origin of the latitude-longitude coordinate system. The other 4 special latitudes are the Arctic Circle, the Antarctic Circle, the Tropic of Cancer, and the Tropic of Capricorn. The Tropic of Cancer is the latitude of the subsolar point at the summer solstice. For an observer on the Tropic of Cancer, the sun will be directly overhead at its zenith on the summer solstice. It is the same value as the sun's declination on that day. The Tropic of Capricorn is the latitude of the subsolar point on the winter solstice. For an observer on the Tropic of Capricorn, the sun will be directly overhead at its zenith on winter solstice. At the spring and fall equinoxes, the sun is directly overhead for an observer on the equator. Zenith is the point in the sky or celestial sphere directly above the observer. It is the elevation or angle of 90 degrees from the horizon. The meridian is an imaginary line from north to south along the zenith. The student is facing south and pointing to the eastern horizon with her left hand. If she turned to circle, her left hand would trace out the entire horizon. We can use the University of Nebraska's altitude and azimuth demonstrator to visualize the local horizon coordinate system. In the local horizon coordinates, the location of a point in the sky is given by its altitude and azimuth. Altitude is the angle from the horizon towards the zenith, and azimuth is measured from degrees east of due north. This is the celestial sphere. There is a north celestial pole and a south celestial pole and a celestial equator. The equatorial coordinate system has right ascension, which are like lines of longitude, and declination, which are like lines of latitude. This figure from the textbook shows us that from the North Pole on Earth, all the stars of the northern hemisphere of the celestial sphere are always visible, and all the stars of the southern hemisphere are never visible. What about when they are viewed from any other location on Earth? From the North Pole, the northern hemisphere of the celestial sphere is always visible. From the southern hemisphere is always below the horizon. At a mid-latitude, there are circumpolar stars and stars that rise and set. At the equator, all stars rise and set. Half are visible at any one time. As the Earth turns on its axis, an observer in the equator has a chance to see all the stars on the celestial sphere. Compare the northern and southern mid-latitude observers. In the northern hemisphere, the north celestial pole is visible and stars rotate counterclockwise around it. In the southern hemisphere, the south celestial pole is visible and stars rotate around it. The north celestial pole is towards the north along the meridian. The altitude of the north celestial pole is equal to your latitude. The celestial equator is perpendicular to the north celestial pole. Draw a line 90 degrees from the north celestial pole towards the south, and the altitude of the point where the celestial equator crosses the meridian is 90 degrees minus your latitude. The summer solstice points are 23.5 degrees above the celestial equator, and the winter solstice point is 23.5 degrees below the celestial equator. If you are observing a star that is the same number of degrees above the celestial equator as your latitude, then the altitude of the star when it crosses the meridian is your zenith. The declination of a star that is just barely above the horizon, southern horizon, when it crosses the north-south meridian is your latitude minus 90 degrees. Observers in the southern hemisphere can see this star, but for the northern hemisphere, it only briefly rises and sets. If your latitude is 90 degrees, then the north celestial pole is zenith and both are aligned with the north pole. If your latitude is 0 degrees, you are on the equator. All stars rise and set, and the celestial equator passes through the zenith. With these hints, it should now be possible and very straightforward to complete the LADA activity number 5.